right, everyone. So thank you for joining me today. Today we gathered for a special case, or for me it is, because it's time for us to talk about Snowflake. I even prepared myself with the right clothing. Today the presentation is going to be an introduction to Snowflake. And we're going to go through Snowflake as this holistic platform, and we're going to try to keep it as high level as possible. Fair warning before we start, this is going to be a hype talk. That means some of the features right now are in preview as we speak. This is a talk that is supposed to give you the idea of what are the potential opportunities for Snowflake for our data first project. So this is the agenda. So firstly, we'll talk about what it's all about, really what's the hype about Snowflake. Then we're gonna get right into it. We're gonna divide our story of Snowflake into 4 parts, and then we're gonna have some conclusions. But before we start, there is some technical jargon that I want you guys to know so that we're on the same page. And we'll start from the first one, which is ETLs and ELTs. ETLs are extract, transform, load. The idea behind this one is basically you have some data sources, you have your custom code that transforms that data, and then you put it into your target operational database or data warehouse. The main idea here really is you take the data and transform it, you make it clean before you move it to your target database. That transformation is usually in some kind of imperative language. That can be Python, Scala, maybe Spark on top of it, this kind of stuff. For ELT, flow is slightly different. The flow is that you firstly load the data into your target database, in this case, in a concept called staging tables or raw tables. So you move that data first, and then you do the transformations to the final stage into final tables on your target database. And for this to work sensibly nowadays, really, you would like to have your database in this sort of concept of MPP database. An MPP database stands for Massive Parallel Processing database. And it's basically this idea where you can, or the database can spring up new computation nodes, allowing you to have in conflicting operations of your data processing. Why you would want to have it like that? Because this way, when you have a lot of operations, those operations don't affect your main DBMS computation node, which obviously would want to be reserved for the application and user connection logic. So basically for handling the traffic. Hence, that's this sort of a concept of having multiple nodes springing in for those parallel computations. And actually, Snowflake is one of those architectures. So having the jargon aside, let's go into what really, or what's the hype all about with Snowflake. So first of all, it all started as this sort of a just data warehouse on cloud. That was its key selling feature. It was basically you have your data warehouse, it's on cloud, the architecture or hardware is provisioned for you, it's abstracted away. Nowadays, it grew into this whole ecosystem that really you could consider like a data layer in your company or a whole data platform with the computation actually abstracted away, or the hardware infrastructure abstracted away through Google Cloud, AWS, or Azure. But that's abstracted away, and you use Snowflake as like a separate entity, basically, from your perspective. And that philosophy can really be seen through this diagram, where basically you start off of having just this interoperable storage of your structured, semi-structured, and unstructured data, which you then have the layer of elastic compute that allows you to really, flexibly perform operations in a SQL, but also in imperative languages. And the GPU or general hardware is abstracted away from you. Then you have this layer on top of AI, which helps you getting the insights. And then you have cloud services that are for managing and governing your data platform within the company. And then finally, you have this layer, the outer ring of SnowGrid, for having basically infrastructure allowing you to have this whole feature set of sharing your data with the outside world. And we're going to dive into all that. So, given this philosophy, can I use Snowflake end-to-end in my data project? Let's find out. Let's start from getting the data. So with getting the data, obviously, you can get the data through normal means, through data warehouse connectors, through Snowflake. But that's not something I want to focus on this deep talk because it's a quite kind of classic approach. Here, I want to highlight the fact that you can also take semi-structured and unstructured data. You store it in your cloud provider of choice, S3, Azure Blob Storage, or Google Cloud Platforms storage, GCS, and you have third-party integration with which you're able to query that data basically directly as if this was table, as if this was structured data. This is an example of such a query, basic query, but yeah, you can see that JSON is basically ending up looking like just a normal table, and you can use that flexibility freely. Now, all of that is able through this elastic compute. So Snowflake gives you the scalability, and it gives you this elastic means in kind of two ways. The first way shown here on this slide is this kind of scalability. You can scale it from small, so like only one node computation unit, all the way to X large, and you can also have it in multi-cluster. So you can have a desired size of a node with up to 10 instances within or nodes within your cluster. So that's two ways of scalability here, but that's one part of being elastic compute of Snowflake. The second part we'll actually dive into a bit more later for all the means and runtimes that you're able to use that compute in. So now we have the data in. Let's get it ready. Let's process that data. Okay, so I mentioned that Snowflake now, with this whole flow of bringing the data into, that kind of means, all right, so we're using ELTs, yes? So if we're using ELTs, that means probably we're gonna do SQL transformations, yes? This is like an example of 3 transformations that you can do in SQL with stored procedures. And you can, I believe, immediately tell that, well, it's maybe a bit too verbose, maybe a bit too cumbersome to do, especially that, like the first example on the left, transformation date columns to US format, that could have been done with just a couple of lines in something like data frame or even one. So yeah, there has to be a better way. And there is. Actually, you can just do your ETLs on Snowflake directly. So here is an example of doing a Python ETL, taking the data of Titanic data set and just, transforming it, processing it to your needs. And this is the mentioned Snowflake compute elasticity. Basically, this runs directly on Snowflake, again, with the compute being abstracted away. So that's much more convenient. But that's not the only way to do it. Like, this is not only doable through Python. This is also doable through Scala, Java, worksheets. And also, you're able to use something called Snowpark run containers or container services, which even allow you to virtualize this whole flow basically into any language. We're going to talk about Snowpark container service later, though. But also there's a third way, there's a middle ground. You can use something called user-defined functions. And this is a way of creating your kind of like a stored procedure, but your logic within an imperative language that's more concise and more flexible, maybe using some custom API call, and basically wrapping it as an SQL function. And yeah, that gives you the flexibility and gives you also like easier out-of-the-box scheduling capabilities. And this is also one of the reasons I think you can use this even when you write the content of it inside SQL. But don't take my word for it, try it out. That's my opinion. All right, we have the data processed. Now let's get into the insights. So you'd be pleased to hear that Snowflake also has notebooks. And again, it's the same story. It's the Elastic Compute that allows you to run this Python notebooks and not worry about the hardware or the computation, and applies the same rules of scalability. So you can run it on the smallest warehouse or the largest one as you wish or as you need. The benefits of having it directly on Snowflake, well, it streamlines the work. So you have everything inside one kind of dev environment with your data, etc., with your maybe your ETL worksheets, etc. But also, basically, you have direct access to your data. And more importantly, Snowflake has a direct access to your data. So also the computations, the transformations are a bit more secure because that data doesn't travel between your DBMS and your place of handling or deployment of the code of the runtime. And also, speaking of compute resources, they're obviously here, again, abstracted away thanks to that elastic compute concept mentioned earlier. Finally, with using Snowflake notebooks, you're able to leverage Snowflake Cortex AI out-of-the-box ML library, but we'll talk about that, of course, later. Then you also have Snowflake Marketplace, which is kind of like Kaggle, you could say. It gives you an easy way, seamless way, basically, to access different data sets published both free and paid on Snowflake Market. There's also connectors on the Snowflake Marketplace. So again, for the traditional data warehouse usages or transform or migrations from different data warehouses where you already have structured data. Plus, there's also third-party tools, like you could use, for instance, some kind of a tool that gives you API data, maybe some geolocation that you want to probably put in your, again, semi-structured data lake, which then you would leverage through Snowflake again. And finally, there is something called full data apps, which, yet again, I'll talk about later. Okay, let's get to something we like the most, which is AI features in Snowflake. So Snowflake is growing its ecosystem of AI tools and capabilities quite rapidly recently. And we can divide their ecosystems into this sort of four divisions, 4 areas. I'll highlight 3 here, all right? I highlighted here 3 of those, and I'll talk about 4th one again later. But let's start from the first one, which is this sort of a feature engineering kind of capability of AI models. So again, hinted a bit earlier, there is something called Cortex AI, and it's this set of out-of-the-box ML or like LLM-powered functions that you're able to call directly from your SQL, Python, Scala, just like the previously mentioned UDF concept. There is a couple of categories or functionalities that you can use: translation, sentiment score, summarization, or classifying text, and more coming. And basically, as mentioned before, you can call it directly from SQL or any kind of your code worksheets or notebooks. And again, importantly enough, it's running on Snowflake's compute. So again, Elastic Compute comes in and abstracts away the necessities for running the model itself. And then let's move on to quality of life and this kind of exploratory data analysis features. So obviously, Snowflake trying to get into this whole hype of Gen AI and copilots. It has a couple of features that you can use directly from UI, not worry about anything in terms of hardware. It's just for this kind of developer experience and data exploration. One of the features is universal search. It's the concept of basically allowing you to have this kind of supercharged fuzzy search and figures out the context of the data that you want to find within your database, within your data platform on Snowflake. That's one. The other one is document AI that allows you to extract information from your unstructured data or even use that data later for training purposes of your custom-made model. And there's as well Snowflake Copilot, which is this very well-known idea by now, but basically in Snowflake context, where it has the access and has the context for your data, and allows you to write a better, more tailored SQL query. So that was some kind of quality of life features and also some out-of-the-box features. Now let's talk about what if you want to have your custom ML model on Snowflake. Well, there's a couple of ways to do that. The very first one is that you can directly do it from your Snowflake notebooks. And there is this whole framework, ML framework, for basically being able to take the data or rather have your model directly trained through the notebooks. So it's ML. So there's three main components that I would invite you to have a look in your spare time. Again, keeping this very high level purposefully. The ML modeling library. So again, the set of you could say framework calls. The feature store, and obviously the model registry for then having the data, or sorry, having the model with the right metadata. But that's not the only way. There's also a further way to do that if you really want to have it custom made, or if you really can't just be satisfied with this sort of a framework that they gave you. There is also a way to fully containerize your whole application through, again, something called Snowpark Container Service, which allows you to basically have any kind of code. Then you can deploy that through something called Snowflake Native App, which we'll get to in section 4. So speaking of, get it shared after you've already had the insights and you already had processed all the data. So there's a couple of ways to do that. First of all, there is a way of Streamlit. So Streamlit is this sort of Python library for making your code more interactive, having dashboards, having different kinds of utilities. Here is an example how to just write it. Again, just like with Python worksheets or with Jupyter or with Snowflake notebooks, just write it directly and enjoy or benefit from the elastic compute. What can you build with it? Well, there is a couple of use cases. So one of them is having basically a dashboard, dashboarding needs, extending that info to your client about the data that you have in your data platform. That's obvious one use case. There is also an option to basically use Streamlit as this kind of a two-way flow, where you basically allow others to feed in the data to your data platform, making, again, this kind of a cycle, you could say, of we will get back to step one, but this is fully possible with Streamlit as well. This is one of the examples of basically just having random data generator, just for example purposes. And you can even write utilities if you want, like, removing background from the images if you even want. So that was one of the ways. The other one, which I only really gonna skim over very briefly for the purpose of future slides, is SnowGrid. Is this layer of infrastructure, let's say, for Snowflake that allows other users to have cross-cloud access to your data. Basically, you share it, and without any deployment, but just with this sort of configuration, they're able to query that data and view it and use it for their needs. Again, not diving into specifics here, but that thing, that concept is then can be fully leveraged also in something called Snowflake Native App, which was hinted beforehand, where when you have your Snowpark container services, when you decided to go that full containerization route, you have basically a way for having your app being a native data app in Snowflake. And thanks to that SnowGrid feature, other people could use that logic of yours basically on their data. And I have this specific example here when I was playing around for the demo or for presentation here. And I found, for instance, one good data app or native Snowflake data app that leverages this concept and uses it fully, which is called Cost Optimizer for Snowflake. Basically, here is an example of I've downloaded it from the marketplace, and it having its own logic from the left side of this diagram here, as you can see. So from their side, containerized, was able to use it and leverage it on my data. Now, obviously, this was a demo instance that I set up for the presentation, so there is a whooping cost of $1, but you can already see the insight that it got in terms of the queries that I used, and also there is even more optimization. Well, there is optimization tips that it gave me, but I specifically omitted it here because I want you guys to try it out in your spare time and see if it gives you also similar tips for optimization. So, in conclusion, is Snowflake able to be used end-to-end on your data project? Here on this presentation, on this deep talk, we went through having the data stored into our data platform of Snowflake. So it answering storage and DB needs, then going through the data preparations through a variety of flexible ways of basically obviously having it through SQL, but also having it through this more like ETL kind of workflows. Then having insights taken or insights and analysis taken from it through Jupyter Notebooks and through the whole suite of the Cortex AI libraries, or even making your own custom models. And then finally up to even sharing the final product, the final data product, also through a couple of ways, one of which was Streamlit and having it as a Python-based app, threads like that, or going it full route of using Snowpark container services and using this concept of Snowflake native app and exchanging the data like that. So, in my humble opinion, yes, it is possible. And I would like to encourage you to try it out yourself. There is a 30-day trial with 400 credits or $400 in credits, and it's easy to get started. There's some great tutorials on Snowflake's website. My personal recommendation is actually the quick start section. It really gets you going very fast and gets you to the meat of what are certain Snowflake features. And finally, there is a lot of demo data to jumpstart learning. And my personal preference is actually the Tasty Bites demo. But I'm a data engineer and it's more focused or tailored for data engineers. Perhaps that's why. And yeah, and with that being said, I'd like to thank you for your time and for listening today. Thank you.